these are the solutions to the quiz at the end of lesson 10.2. Now number 1, we've got A, because a smaller wavelength will mean that sine theta is smaller, and so the spot is smaller. Now number 2, we have C, because the size of theta, the Rayleigh angle, is 1.22 lambda over d. Now our best resolution means that theta r should be a minimum, which means that lambda should be a minimum as well. So that'd be violet light. Now 3, we've got a calculation here. So we have the satellite looking down at these two things 1.4 meters apart, and the distance is 1 by 10 to the 6 meters. So using the small angle approximation, theta is about equal to 1.4 over 1.0 by 10 to the minus 6, which is 1.4 by 10 to the minus 6. Now we have lambda is 600 nanometers. So we have 1.4 by 10 to the minus 6, this is our criterion, is 1.22 lambda over d. So that means d is 1.22 lambda over theta r, which is 1.22 by 600 by 10 to the minus 9 over 1.4 by 10 to the minus 6, which is 0.52 meters. So at the end of all of that, the answer is E. Now number 4, we have intensity is a term that is because of the interference, and that depends on the slit spacing d, and then we have the term because of the diffraction that depends on the slit width a. So we have beta equals pi d over lambda sine theta, alpha equals pi a over lambda sine theta. So the d is our interference term, the a is deciding the diffraction. So we have dark fringes when theta dark, sine theta dark, equals m lambda over a. So we'll call that M1. So M1 is 1 here. This is the first minimum for the diffraction. So that happens at 4 degrees. So here we have sine of 4 degrees equals lambda over a. Now that first dark fringe for the diffraction corresponds to the fourth fringe for interference. So remember that m equals 0 is at the centre, and then it is 1, 2, 3, 4 away. So for interference, we've got m2 is 4. And so going from our equation for the maxima for interference, so because it's a maximum that's missing, we have m lambda equals d, this is m2, sine theta. So 4 lambda equals d sine of 4 degrees. And so let's get 4 degrees as the subject here, of sine of 4 degrees. So sine of 4 degrees equals 4 lambda over d, because we also had sine of 4 degrees up here. So we now have lambda over a equals 4 lambda over d. And we will cross multiply, so we have d lambda equals 4a lambda. Cross the lambdas out, d is 4 times a, and we know that a was 25 microns, so that gives us the distance is 100 microns. And often these problems where you've got diffraction and two slits come down to a simple question of ratios. We didn't even have to work out lambda here. Now, 5. The equation for the angle of the first dark ring is 1.22 lambda over d. And that is 1.22 times lambda was 532 nanometers, which is 10 to the minus 9. And the diameter was 100 microns, which is 100 by 10 to the minus 6, which is 0.0065, which is about equal to, sorry, that was sine theta dark, but that, of course, is about equal to theta dark because it's a small angle. So we're looking at this distance of 1.6, and from the center line to what the first dark fringe is, so this is y, and we've now got the fact that this angle is 0.0065. So we get y equals d tan theta 1.6 times theta approximately, since it's small, 1.6 times 0.0065, which is 0.01 meters, which is 1 centimeter. So the width of the whole slit, which is double y, width of the whole disc, sorry, the airy disc, equals double y is 2 centimeters. Number 6, we have distance apart for these stars is 3.7 by 10 to the 11 meters. We want to know how far they are from us. So this is actually the small distance, 3.7 by 10 to the 11. This is some larger distance away from us. Now we have the diameter of the telescope, 1.02 meters. Lambda equals 550 nanometers. So the criterion theta r is 1.22 lambda over d, which is 1.22 times 550 by 10 to the minus 9 over 1.02 equals 6.57 by 10 to the minus 7. So now we have y over L, or D, it was actually D it was called in this question. D over L is theta r, so D equals L times theta r. And then we have L equals D over theta r. So we have 3.7 by 10 to the 11 meters over 6.57 by 10 to the minus 7. That gives us 5.6 by 10 to the 17 meters. Now, number 7, we have a wavelength of 1.6 centimeters, diameter of 2.3 meters. The distance away is 6.2 kilometers. So we have 6.2 by 10 to the 3 meters, and this is going to be y here. So we've got y over that is 1.22 lambda over d, because that is tan theta. So that gives us y equals L times 1.22 lambda over d, which is 6.2 by 10 cubed times 1.22 times 1.6 by 10 to the minus 2 for 1.6 centimetres over 2.3 is 52.6, which we will call 53 metres.